everyone. My name is Farprakay Jiarakoopt, Public Outreach Officer, National Astronomical Research Institute of Thailand. Today, I would like to show you some the interactive astronomy exhibition in Astropark and how to apply those ideas to classroom activity. Moon phase is the shape of the moon gradually change over a month. Many people are thinking that it is caused by the shadow of the Earth cast on the moon. But what causes phases of the moon? Let's find out the answer to the exhibition. Let's say the yellow sphere represents the sun, which install a light bulb inside. The white sphere represents the moon, and the blue sphere represents the observer on Earth. Instruction 1. Stand behind the Earth. 2. Touch the Earth and walk counterclockwise around the table. 3. While doing so, observe the appearance of the moon that has sunlight. We find that the phase of the moon is not caused by the Earth's shadow cast on the moon, but determined by a fraction of the moon from which we see reflected sunlight. Different phases depend on the different angle from which we see the bright part of the moon's surface. This model can be applied in the classroom activity by using simple equipment. 1. Lampset represents the sun. 2. Ping pong ball or foam ball with a skewer as a handle represents the moon. The larger size of the ball can help us to see surface brightness clearly. 3. Represent yourself as the observer on Earth. Instruction 1. Hold the moon and stretch your arm. 2. Turn counterclockwise. 3. While doing so, observe the appearance of the moon that has sunlight. Have you ever wondered why the sky is blue? Many people have misunderstood that caused by the reflection from the sea, which covers about 75% of the Earth's surface. But have you ever seen the sky in the morning or evening? What color is it? Absolutely. It is orange or red. So the color of the sky is definitely not caused by the reflection of the sea. So what is the cause? I will take you to learn through this exhibition. The model, which contains translucent liquid inside, represents the Earth's atmosphere, and the light bulb represents the light of the sun. Instruction 1. Rotate the apparatus so that the flat side faces the light bulb. Observe the color of the fluid inside. Notice how the color is white, resembling the midday sun. Because sunlight travels through the atmosphere for a short distance, short wavelengths such as purple and blue light will scatter first. The human eye is more sensitive to blue light. Therefore, we saw the sky turn blue. 2. Rotate the apparatus so that the edge faces the light bulb. Observe the color of the fluid inside. Notice how the color of the fluid is yellow to orange red, resembling the sunset and sunrise. Because sunlight at that time travels through the atmosphere over a longer distance, the short wavelength is scattered. Only long wavelengths such as orange and red can pass through, make the morning and evening sky orange or red. This model can be applied to classroom activity too. 1. Fill the transparent container with water. 2. Add a few drops of milk into water. The fluid inside represents the Earth's atmosphere. 3. The flat line represents the light of the sun. Instruction 1. Project the floodlight through the fluid on the long side of the container. Observe the color of the fluid from the opposite side. Notice how the color is white, resembling the midday sun. 2. Project the floodlight through the fluid on the white side of the container. Observe the color of the fluid from the opposite side. Notice how the color is orange, resembling the sunset and sunlight. The last exhibition which I would like to show you today is Foucault pendulum. This exhibition is very interesting because there is only one in Thailand. The Foucault pendulum is one of several experiments that prove the Earth's rotation. And how does it work? Let's find out the answer through the exhibition. If we hang a pendulum from the ceiling and observe its trace direction pattern, then we will find that the pendulum gradually changes direction under a mystery force affecting it. Physicists call the apparent force as the Coriolis force, which occurs when an object is moving on another object. In this case, a pendulum is moving on a fixed plane, and the Earth rotates beneath it. The extent of this effect depends on those pendulums located on the different latitude. This is one of several experiments that prove the Earth's rotation. Latitude of Chiangmai is 18.795 degrees north. A pendulum will shift for 115.98 degrees clockwise in a day. I will take about 3 days to get back to the origin. This model can be applied to classroom activity too. The same rule with our exhibition. We reduce the size of the model, but this board is really an upside-down pendulum. Instruction 1. Make sure the rod with the steel board is pointing straight up. 2. Pull the ball to one of the notches on the ring and let go. 3. As the ball weighs base, use the handle to slowly and smoothly rotate the base. Watch the back and forth direction of the ball. Does it change as the ball rotates beneath it? 4. Repeat the experiment again with different angle of the rod and steel ball. Notice the difference in the movement of the pendulum. With the state-up position, when the base rotates 90 degrees, the pendulum will also rotate 90 degrees. For the 45-degree position, when the base rotates 90 degrees, the pendulum is rotated halfway. But at 0 degrees, the pendulum will never change its direction from the origin. These are just a sample of exhibitions which we developed for students in Thailand. I hope this information could help you to get a new idea and easily deliver this idea to apply with your classroom activity. Thank you.